Once we have an idea of the center of our data set, be it mean, median, or mode, we'll also have a sense of certain data values that may negatively impact our interpretation of the larger data set. Those data values are called outliers. And it's a data entry that is far removed from the other entries in the data set. A data set can have one or more outliers, causing gaps in the distribution. We're going to develop criteria to determine when we have outliers, and we'll most likely want to analyze our data with the outliers removed, because conclusions that are drawn from a data set that contains outliers may be flawed. So looking over here, this data set of ages of students, we want to look at the mean, median, mode, figure out which one best describes the typical entry in this data set, and then we want to see if there's any outliers. So to begin, the mean, x bar, since we're dealing with the sample, is the sum of x over n. If you were to add up all of these data points, you end up getting 475, and there was a total of 20 of them. So our mean is roughly 23.8. Now the median, since this is already ordered, we just go from each side, taking one off at a time until we meet somewhere in the middle. Since we have 20 values, if we move from this side and from this side simultaneously, we'll land right at these two. And since it's an even number of data entries, we take the average for the median. So the median is going to be 21 plus 22 all over 2, which gives us 21.5 as the median. And then the mode, we just have to look this over, and we see that there is a majority of 20-year-olds, and so our mode is 20. Which one typically best describes this? I would say the median. That's up to interpretation, but it seems that the majority of things are happening around 21.5. Now, with regards to outliers, we have this one 65-year-old, which is way far off from our next oldest student of 24. So I would consider this an outlier. Next, we can talk about these things called weighted means, which is a mean of a data set whose entries have these varying weights. And it's defined to be x bar, which is equal to the sum of your value times its weight all over the sum of its weights, where w is the weight for each entry x. Think a little bit about where you've seen weighted means before. This next example kind of gives it away, but class averages are an example of weighted means, right? Certain categories have different weights, and those contribute differently to the overall average. For instance, you're taking a class this semester where the breakdown of the categories is your test mean, your midterm, your final exam, the computer lab, and the homework. These are the scores that you got, and these are the weights associated to each one of these categories. So your test, the average of your test, make up 50% of your overall average, whereas your computer lab only makes up 10% of your average. So in this class, the minimum to get an A is 90. We're asked, do we get an A this year? What we want to do is we want to extend this column out, or this table out, by one more column and do x times w. So we're going to take 86 times 0.5, which gives us 43. 96 times 0.15, which gives us 14.4, and then we just keep doing this. And that's our x times w. Next, we take the sum of this column. So we just add all of these up, which gives us 88.6. Now, we add up the weights, and since we're talking about something in a class, this should add up to 100. There's 50, 65, 85, 95, 100%, which gives us a 1 for the sum of the weights. And so unfortunately, because we got an 88.6, we did not get an A. So notice that certain categories, when they weigh more, affect the overall a lot, right? Because you getting a 98 in the computer lab and a 100 on the homework, those two together didn't really contribute as much as, say, getting an 82 on the final. Or even getting the midterm, computer lab, and homework, which comprises of 40%, 30%, sorry about that, 30%, it still didn't outweigh the fact that the test and the final exams were in the mid to low 80s. Now, when we have ourselves a frequency distribution where we don't know exactly what the values are, but we know how many things are actually in each one of the classes, we can start talking about a mean of a frequency distribution. Right, and that'll give us an approximate mean of the distribution. And what we do is we take the sum of the midpoint times the frequency for each class, divide it by the number of entries altogether.